So in the previous video we just extracted the IPS and the laptops which are having touchscreen, and we saw how touchscreen and IPS give a variation in the price of the laptop. Okay, so now we will try to extract the resolution. So for that, extracting the X resolution and Y resolution, we will split the text at X and then separate the two parts. What do I mean by that? If we just have a look over here, we will separate the text at this. So if we just look in a sample resolution, what a sample resolution looks like normally, a sample resolution looks something like this, right? Over here. So if we want to split them in two parts, what would we do? We would say before X some part is there, and after X some part is there, right? So before X what part is there? 2560, and after X what part is there? 1400. So we will be splitting in that way. Okay, so that's what is said over here. Split at X, n is equals to 1, expand is equals to 2. Expand is equals to 2 in the sense means whatever is there in before 2560 also take that into consideration, even if it's a blank space. So if you see over here, before 2560 everything is considered, even blank space is also considered, full HD, everything, right? Got it. So now so we will execute this. So we will get a split df, then we will say split df is equals to df of screen resolution dot split of this thing, and df of X resolution is equals to split df of this thing and that thing. That was just for a sample, and now we get X resolution and Y resolution. This thing is just replicated over here, just the name of the column is changed, that's it. This is nothing but to see if this is working or not, that's it. Okay, so over here if we execute this, we get the X resolution and Y resolution. Now so basically from the whole text of X resolution column we need to extract digits from it, but the problem is number are scattered in some cases. The reason why I am using regex is this will exactly get the numbers what we are looking for. So regular expressions are a very powerful tool when we want to extract some kind of numbers or characters or special symbols from a very huge chunk of text. And I must say that regular expressions form a base for natural language processing. Regular expressions are heavily used there, and they are widely used wherever there is a textual data. So here also we see that we need to extract numbers. So from this we need to extract numbers, right? So we don't know the exact position of the number. So for that the reason we are using regular expressions. So over here, what does this mean is just look at the regular expression what we are saying. First we replace all the commas with spaces. So so in the data frame, if you explore the data frame a little bit, we find that there are few columns, a few rows or tuples which are having commas. So we have to replace those commas with what we say some space, and then we will find all the text rows which are satisfying this kind of regular expression. Now what is this regular expression all about? Now over here we see that /d plus dot question mark /d plus. Now /d means that is the integer number, okay, and slash dot question mark means all the numbers which come after a number, and /d plus the string must end with a number. Got it? So if we consider this kind of text over here, IPS panel display, let's say that we consider this text and we paste it over here. So we see that now if we try to match this, okay, so what we will be matching here is we will be first looking for the number. So where we are getting the number? We are not getting any number, we are not having any like commas or anything. So this will get this will get passed, no problem. Then over here we will see that we found a number over here, that is this, and we will see if there is any dot or not. There's no dot. Okay, then at the end also, is the end having a number? Yes, this is only the end. This part is the starting and this part is the end. That is also a number only. So we will extract this, right? So that is the thing which we have applied here. So this is a regular expression. Maybe you maybe there might be little bit of confusion. So what do I suggest is you take some sample rows and try to use them exactly by using this regular expression, and see on some samples, and then better you'll get an understanding of it. Okay, so once we get the X resolution and Y resolution extracted, the next thing is we need to convert it into integers. They are not integers, they're text. Basically we applied regular expression on text, we didn't convert those things into integers, we need to convert them. So this code does that. So let me execute this. I got X res and Y res, and then let me execute this as well. So we see that X res and Y res is now integer. Now let's look at the correlation map. Over here we see a lot of correlation among X resolution and Y resolution, and that is true because X resolution and Y resolution are almost like very close to each other also. That's not an issue. We'll see how to manage that in a while. Okay, let's see the correlation of features with price. We see that RAM gives a very good correlation. RAM is a good correlation. X resolution and Y resolution, like the resolution of the laptop, that is the screen size, like 1920 into 1080, full HD laptop, ultra F4 HD laptop, 4D laptop, all those things, they come under resolution. So we see that almost like 55% is affected. The price variable is affected almost like 55% with the resolution only, and we see that the 74% of the data has been affected with the the RAM. So RAM, and from this correlation we can say that resolution and RAM are very, very important features. We cannot remove them, right? So that is what I have written over here. Now what we need to do is, even though X resolution and Y resolution, they are very important, we see a little bit of pattern over here. We see that this is like 55 and 55, right? Maybe kind of they might be under a clash. Got it? So we have to remove it. So this might be a case of multicollinearity, when multicollinearity is a situation where more than two features are contributing the same kind of thing. Then that may affect the overall outcome. That must not happen. So what we will do is we will combine these two things, and we will create a new feature out of it. Simply some persons drop any one of them, but as in laptops there is something known as pixels per inch, so we will create that feature using the X resolution and Y resolution, and there is a formula for it as well. So X resolution and Y resolution, the pixels per inch formula is X resolution square plus Y resolution square by the total number of inches. We have the total number of inches column, we have X resolution also, we have Y resolution also. Why not, instead of deleting any one of them, why not use both of them and create a new feature, right? It may be a good suggestion. So we are doing the same thing here. So we are creating the same simple kind of formula. The same formula has been translated into code over here. This is nothing but X resolution square, this is nothing but Y resolution square, star 0.5 is nothing but square root of X resolution square plus Y resolution square, and the entire thing is divided by inches. And inches, it was a string, we converted into a float, so that is why df of inches dot as type of float. And then when we shift enter and see, we got a pixels per inch thing over here. So and then if we just try to see the correlation here, yeah, so this is see X resolution and Y resolution, using X resolution, Y resolution, and inches. This was already low. These two were very high and were battling against each other. So we combined all the three and we made a very good feature named as PPA, and that is contributing almost like 48% to the price. So now this has become a competitor with X resolution, Y resolution, and inches. And now as we made this feature PPI using this X resolution and Y resolution, we can delete them because we got a very good feature instead of using this combination of three. So this is a kind of feature reduction by using a new addition of feature. So correlation analysis also plays a very vital role, and that is the reason I was saying in every video I am saying that exploratory data analysis and data pre-processing in this project is very important. You at every doorstep you'll get to see some kind of insights into this. So yeah, we saw that these two, so in this we saw that these three features could be combined and then we could make a new feature here. Okay, so we'll talk about more about pre-processing in the next videos coming up.